Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over uncertainty in measurements and I'll go over some example problems. So let's get into this. So unless you're told otherwise, the uncertainty of your measurement is plus or minus of the last digit or plus or minus one of the last digit of your measurement. This will give you basically the highest and lowest value in the range of acceptable values that are within the margin of error of your measuring instrument. So all of this is to say is that there's always some built-in um, error in your measurement. And so the way we express that is either plus or minus one of the last digit. So the plus one, basically what that means is you're going to add one to the last digit or you're going to subtract one from the last digit. And so by adding one to the last digit, that'll give you the highest value or highest measure that's within the range of acceptable measurements from your measuring tool. And then if you subtract one from your measurement, that'll give you the lowest value. And so that's your margin of error within those two values. So let's get into this. So here are some example problems. So let's say I measured 5.4 milliliters. Now, unless I know something different, I'm going to assume that the uncertainty is in the last digit, which is the 4 here. Now, some instruments are going to indicate that the percentage or the difference is more than that. Like, so sometimes you have a measuring device that says that the error is about 5% or 2% or plus or minus 2 or something along those lines. So unless your instrument says otherwise, you assume it's plus or minus one in the last digit. So here, since 5.4 milliliters, the last digit is 4, my uncertainty is going to be in the place of this digit. What does that mean? That it's going to be plus or minus 1 in this place here. So since the 4 is in the tenths place, then my error, my plus or minus 1 is going to be in the tenths place itself. So the way I would write that is I would just add to the measurement plus or minus 1, right? Plus or minus 1. Oops, sorry. My bad. So it would be plus, again, plus or minus. And then it's going to be plus or minus 1 in the tenths place. So I would write that as 0 point. And since my number is 1 over from the decimal, then my 1 is going to be 1 over from the decimal. So my 1 here is in the tenths place. So my error, my uncertainty is plus or minus 1/10 because my 4 is in the tenths place. So this is 4/10 plus or minus 1/10. So that means my range of acceptable values that are within the error margin or margin of error, sorry, is going to be 5 point, and so I could add 0.1 to this. So 5.5 to, and then I could subtract 1 from this place. That would be 0.3. So I subtract 1, it would be 5.3. So this would be the acceptable range of error that I have in my instrument. So this would be the highest value. This would be the lowest value. All right, so what about B? So the last digit for 64 centimeters is, again, the 4, but this time the 4 is in the ones place. So that means that I'm going to be adding and subtracting 1 from the ones place. So I would write that by, oh, and I forgot one thing here that's really important, is the units, right? So it's going to be plus or minus 0.1 milliliter, right? So I'm going to subtract or add 0.1 milliliters to my measurement to get the range of measures. So again, that's going to be 5.5 milliliters to 5.3 milliliters. So within that range. So again, going back to B, we have 64 centimeters. So I would add plus or minus 1. Oops. So that's going to be plus or minus, and then it's going to be 1 in the ones place. So it's going to be plus or minus 1. Instead of 0.1, it's 1 because 1 is in the ones place here. So that means my range is going to be from, so I add 1 to the ones place. So to the 4, I add 1. So that's going to be 65. So 60, oops, I almost forgot again. Centimeters, that should be 1 centimeter. So I'm going to add or subtract 1 centimeter from my measurement, and that's going to give me 65 centimeters when I add 1 to the 4. And if I subtract 1 from the 4, that's going to give me 63. So 63 centimeters. So that's the range of values that are within the margin of error from the uncertainty of my measurement. So for here, again, this is going to be a little bit tricky when you have scientific notation. So you don't want to jump to the conclusion that, oh, here's my last digit, which is a 4, right? Oh, and look, this is the 1, this is the 10th place, this is the 100th place. Oh, so therefore it's going to be plus or minus. Why do I keep doing that? So it's going to be plus or minus. And then, oh, it's going to be 0.01 kilograms, right? Because notice that, hey, my 4 is in the hundredths place, therefore my 1 is in the hundredths place. But that would be great if you were like dealing with non-scientific notation. But the problem with scientific notation is that this decimal point has been moved. Right? When you write a number in scientific notation, you move the decimal point to get it into the scientific notation form. And so that throws things off a bit. So what you have to realize is that you have to get it back into standard notation. But you can't always do that because sometimes these numbers are so large or so small, to rewrite it out in standard form is not going to be practical. So the way you want to go about this is whatever the last digit is, you move the decimal point to the right of that last digit. So when you move it over, for this one, it's going to move over 1 and then 2. So I had to move the decimal point over 2 times. And when you move the decimal point over 2 times to the right, you're making this number bigger. And so you need to make the exponent smaller. So you need to subtract 2 from your exponent. So since I moved it over twice, I'm going to subtract 2. And so that's going to give me 10 to the 1. So 10 to the 1 is going to be the tens place. So instead of this is going to be plus or minus 10 to the 1. 10 to the 1, or just 10, right? So here it's going to be kilograms plus or minus 10 kilograms. So that's the uncertainty in the measurement here. So it's going to be 2.34 times 10 to the 3 kilograms plus or minus 10 kilograms. So then the range here is going to be, you add 1, right, to the 4. And just to kind of clarify this, let's write it out for this one since it's quite easy to write out. So here it'd be, if I write this out in standard notation, it'd be 2,340 kilograms, right? So the uncertainty would be in the tens place here, and this 0 is not significant. So when you write it out, you can automatically see right away that the last digit is in the tens place. So it's going to be plus or minus 10 for this measurement, right? It's harder to see that when it's written in scientific notation, but when you write it out like this, it's easy to see right away. It's so obvious now. But in a lot of these numbers, as I said before, you're going to have numbers like 1.3 times 10 to the negative 50, or 1 times 10 to the negative 23, or positive 36, or something like that. You can't write those numbers out in standard notation. So the way to go about it is to move the decimal point to the right of your last digit, count the number of times you move it over to the right, and that number is the number you're going to subtract from the exponent. Now, if your exponent is already negative, then it's going to become more negative. You're going to subtract out the negative number. So that's like adding a negative number, right? So if this was, for example, a negative 3, and I moved it over twice to the right of the decimal of the last number, then I would have to add a negative 2 to that. So instead of a negative 3, it would be a negative 5. So I'll show that down here in a moment. Okay, so then what's the range of this? Then it would be, again, you can keep this in scientific notation. So then it would be, let me write it down. I'll write it down here since I have more space. That would be, or I'll write it here. So it would be 2.34 times 10 to, instead, okay, so I'm going to add an exponent. So I'd add 4 here. I'm sorry, not the exponent. I can keep the exponent the same. So it'd be, I'm going to add 1 here because it's the last digit. So 2.35, excuse me, to 10 to the third kilograms, and then that's going to be the highest value, and then the lowest value is I subtract 1 from the 4, so it would be 2.33 times 10 to the third kilograms. So in writing your range, you can keep it in scientific notation, and you're just, again, adding and subtracting from the last digit. So this part is the same as before. There's no difficulty here. But when you're trying to figure out where the number is as far as its placement in the number in your measurement, that's a little bit harder. So following this method works with any number in scientific notation. All right, so let's do D now. So for D, we have 8.23. The last digit is the 3 here. The 3 is obviously in the hundredths place. So here it would be plus or minus, and then 1 in the hundredths place, or so 1/100th, so 0.01. So since this is in the hundredths place, your 1 is in the hundredths place, and that's going to be meters. And here I'm going to add and subtract 1 from the 3. So I add 1. That's going to be my highest value. So that's going to be, the range is going to be 8.24 to, and then I'm going to subtract 1 to get the 8.22. So then I get 8.22 meters. I should, again, use my units. Don't forget the units. So 8.24 meters to 8.22 meters. And so there's the range of values for that measurement. And then finally here, we have scientific notation. And so what I'm going to do to get my actual value for my uncertainty is I'm going to move the decimal plate over to the right. So 1, 2, I'm going to stop to the right of my last digit. I had to move it over twice. So that means I'm going to subtract 2 from my exponent. So subtracting 2 from -5 is like adding -1, right? Or -2, excuse me. So adding -2 to -5 is -7. And so therefore, my uncertainty is plus or minus 10 to the -7 grams. So that would be my uncertainty. And I'm not going to write that out as 0.000001, right? Because that would be too long. So I leave it in scientific notation, so 10 to the -7. So this is the uncertainty of this measurement. And again, when I write the range of it, your highest and lowest value, all I'm doing is adding and subtracting from the last digit. I can keep this in scientific notation. So let me write it down here. So if I add 1 to my last digit, that's going to be 4.56 times 10 to the negative 5 grams. And then I subtract 1 from the last digit, and that's going to give me 4.54 times 10 to the negative 5 grams. So then this is my range of values. So here's my highest value, here's my lowest value, and then that's how you do it, ladies and gentlemen. So I hope this was helpful. If you enjoyed this video, and if this was helpful in any way, then please, by all means, like this video, hit that like button. Also, subscribe to my channel, hit that notification bell so you can be notified by other videos that I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.